We are going to start with NCERT Class 10, Chapter number 1, which is a chemistry chapter, chemical reaction and equation. And this chapter would be covered up in 3 or 4 videos, part wise, right? So today is the first video that I would be uploading. So let's start without wasting any time. So the chapter is chemical reaction. Before starting, we already have observed a lot of things, right? Where the product, that is a final thing that is formed, cannot be converted back into the original form. For example, if you burn paper, what happens? The ashes that are formed cannot be converted back into paper, so that is a chemical reaction, which is a permanent reaction. Along with that, we have, when you cook food, you cannot convert raw material back into, you cannot convert cooked food back into the raw material, digestion, growth of a plant, growth of human beings, and so on. All these are chemical reactions because once they take up, you cannot convert them back into the original form, right? So in this chapter, we are going to deal with the equations where any reaction, chemical reaction, will be taking place, and we'll be discussing what all observations and are being observed, any color change or any product that you can see, maybe a colored product, a precipitate, and so on, right? So now these are the examples that they have quoted in NCRT. Fine. And now we start with the main chapter, that is, if the reaction is taken where you take a magnesium ribbon, right? Magnesium ribbon, and you need to hold it with the help of a tongue and you burn it on Bunsen burner. First of all, you will observe a dazzling white flame. Dazzling means something which is very, very bright, means the flame would be so bright that you will find it difficult to even open up your eyes and look look at the flame, right? So first is you will observe the dazzling white flame, and along with that, the ribbon will be converted into white residue. Fine. So you will see in this chapter, we would be dealing with some of the reactions, and then we'll be writing the equations that are involved along with the observations, whichever would be there for each and every reaction. Fine. So in this case, when you burn, you observe a dazzling white flame. Along with that, you get a white residue. Fine. So what is the chemical reaction that is taking place? Let's see. So the first thing that you will say is you have a magnesium ribbon. So the formula for magnesium ribbon would be Mg. Because you are burning it, burning means you are burning it or you're heating it in presence of oxygen. So the formula for oxygen is O2. And along with that, what will you get? You'll get a white residue. Formula for white residue is MgO, right? So this is what the chemical equations will be for this particular reaction. And now the very important thing is balancing. Balancing I would be covering up as we proceed in the chapter. Just we are writing the equation. That's it. Fine. So now you have to remember what all things we observe. We observe dazzling white flame, and secondly, we get white residue as soon as the flame, it is put off. You get a white residue, right? Formula for white residue is magnesium oxide, and this is a chemical reaction. Why? Because once you get this white residue, you cannot form magnesium ribbon out of it, right? So now the next is, now they are asking, what do you observe? So magnesium ribbon burns with a dazzling white flame. Yeah, right. Dazzling white flame word is very important, and change into white powder. The formula for white powder is magnesium oxide. Very, very important, right? So it's already written here, and I told you before that. And the reaction is a chemical reaction because you know that once a product form cannot be converted back into the original reactant, right? So this whole thing is important. Now the next activity or the next set of chemical reaction is, what will you observe, right? The second equation for this is, what will you observe? Okay, now what do we take? we take a conical flask, right? And along with that, we take zinc granules. Zinc granule basically are the small pieces of zinc that we usually take, and we put sulfuric acid. You can put sulfuric acid dilute or you can put hydrochloric acid. Observations would be similar, right? So now when you put it, and before doing it, before putting this, what you have to do, you have to place a cork with a tube, right? And then you have to note your observation. So as soon as you put, dilute sulfuric acid and zinc granule, after probably maybe some time, you'll observe small small bubbles here, right, in the conical flask, right? And now it means, see, if you observe bubbles, it means that some gas is being evolved, right? Some gas is being evolved. So in order to test the gas, what do? We bring a lighter or a matchstick on the top here, right? And what will you observe? As soon as you bring the, you know uh, probably a matchstick, burning matchstick, you will observe it burns with a pop sound, right? You'll hear the pop sound. Along with that, you will see the flame that is mostly yellow in color will turn blue, right? The flame will turn blue. So two observations, not two exactly, three observations you can see here. First is you will observe the bubbles, right? You will test the gas. When you test the gas, you observe that it burns with a pop sound and the flame turns blue in color, right? Also, one thing more you will observe that the content will get heated up. If the content is getting heated up, means heat is being evolved, means it releases heat, right? So this is important here. So now we okay, so after all these things, so we are going to write the equation. So zinc granule formula is zinc plus, if you are taking sulfuric acid, formula for sulfuric acid is H2SO4 gives, okay, so the gas evolved is hydrogen, right? Along with the salt is formed. Now this is being already evolved, right? This has gone. So zinc and sulfate. Formula for zinc sulfate would be ZnSO4. How do we write the formula? I hope you have done it in class 9, the crisscross method. Formula for zinc, when zinc ion is Zn plus 2. For sulfate is SO4, 2 negative, right? 2 get cancelled out, so formula becomes ZnSO4. So that is why we have written ZnSO4. Or if you take, say, HCl, so what formula you're going to write, what difference you'll see? The observation would be same, that is gas is being evolved. That would be same, but your equation will become different. HCl gives hydrogen is being evolved. Now the salt would be zinc chloride, right? Zinc chloride. Again, why ZnCl2? Valency for zinc ion is Zn plus 2. For chloride is minus 1. Crisscross. This one will go here and 2 will come here, but we don't write 1. So the formula will be ZnCl2, right? Again, I'm telling you, I have not balanced the equation, right? Just written the equations. Now the next is chemical equation. So, of course, as already discussed, for the first case, the reaction was Mg plus O2 gives magnesium oxide. And we all are aware of the fact that this thing, which is written on the left hand side, which is written on the left hand side, is reactant, the ones which are undergoing a chemical reaction. So that is written on the left hand side and they are called reactants. Arrow shows where the reaction is actually going, so it is going from left to right, and on the right hand side we write the final thing that we obtain. So in this case we get magnesium oxide. So make sure that you remember the observation. So the what was the observation? We know magnesium oxide is white residue, right? Observation means something that you can see, smell. Of course, we don't taste the chemicals, that should not be the case involved here. So, something that we can see, we can smell, right? So that has to be included in observation, right? And so the left hand side is said to be reactant. And what does a plus sign shows? Plus sign shows which all chemicals are involved. So if you have a one reactant, so we just write only say magnesium. In most of the reaction, you will see that if something is combining, you'll have more than one reactant, right? So in this case, we have magnesium and oxygen. We write plus in between. Plus shows that these two together are forming a new thing, which here is magnesium oxide. Now the next thing is written already, magnesium and oxygen gives you this. Now how to balance the equation, this is important. Suppose you have this equation. So one thing you have to remember is that a chemical equation always follows law of conservation of mass, means the number of reactants which are reacting should be equal to the product number of products that are formed, right? So like for example, in this case we have one magnesium on left hand side and one magnesium on right hand side. It is completely balanced because their number is same. But if you see the oxygen here on the reactant side is 2 and on the product side is only 1. So it shows that oxygen has to be balanced. So we write the numbers in front of the element or a compound. We don't write at the bottom. Fine. So how are we going to do this? So now see here in this case, oxygen is 2, this is 1. So what am I going to do is I'm going to make them equal. So how do we make them equal? We just write 2 in front of it. Why I've written 2? Because oxygen is 2, right? If you want to write the numbers, again I'm repeating, the numbers are written in front of a element or a compound, not at the bottom. Fine. So if this is 2 written here, what happens? This 2 is meant for both the element. If you're writing 2 in front of a compound, so means 2 would be considered for all the atoms that are involved in formation of compound. So it means this magnesium also becomes 2, oxygen becomes 2. Now the problem is oxygen is balanced because you have already written 2 in front of it. But what about magnesium? It is not balanced. In order to balance it, so you have to write 2 in front of this magnesium also. So your final answer would be magnesium plus O2 gives MgO. So this was unbalanced. So we write here 2, we write here 2. So 2 is written means magnesium is 2. Here also magnesium is 2. Oxygen is written 2 here. Here also it is 2. Why? Because in front of MgO 2 is written. Right? So this is one of the equations that is balanced. Now after that, let's do the balancing for a little you can say tricky reaction compared to the previous one. Not that tricky, it's easy, but yes, you have to understand it carefully because it involves total 4 elements, compounds and everything, right? So here, let's start from the left hand side. Left side and right side should be same, should have same number of atoms. So if you take zinc on this side, zinc is 1, here also it is 1 on the product side, so that is balance. Hydrogen is 2. Why 2? Because 2 is written at the bottom, so this 2 would be counted. So here also it is written 2, means it is also balanced. Now what about sulfur? Remember, take each and every element as a single element, not together. Don't take sulfate together. Try to break it into the atoms from which it is formed. Now, sulfur is 1. Here also sulfur is 1. Oxygen, in total, you have 4. Here also we have 4. So, means this equation is already balanced, right? Because the number of reactants and the number of products are same, right? They are same. So it's already balanced. Fine. Now, next we have, yeah, suppose if we try to balance this equation, this would be probably the last equation for this video. Now, try to see. Here iron is 1, here it is 3. So it's understood in order to balance it, you need to write 3 in front of the iron, which is only single. Fine. Now, oxygen here, sorry, hydrogen here is 2. Here also it is 2. That is absolutely fine. But what about oxygen? Oxygen here is 1. Here it is 4. So you need to balance it. In order to balance it, you have to write 4 here in front of water. But if you write 4 in front of water, what will happen? Hydrogen, which was originally 2 in number, it would become 8. How come it has become 8? Because the number which is written in front of an element or a compound or a molecule, with that number you have to multiply each and every atom. Here oxygen was all sorry here hydrogen was already 2 in number, so 2 into 4 becomes 8. For example, if I write say H2SO4, right, and I write say 3 in front of it, so what will happen? Hydrogen was already 2 and you're writing 3 in front of it, so it will become 3 into 2, that is 6. Sulfur would become 3. And what about oxygen? Oxygen is 4 written here, 4 into 3 it becomes 12. Right, so I hope this part is clear because it's very important to understand, because we can make mistakes here in this part. So yeah, coming back to this part again, now I was saying that this becomes 8. This is already 2 in number, and how you will make it 8? If you write 4 in front of it, right? Okay, if you're thinking we write 8 in front of this and it becomes 8, no, it's not the case, because 8 would be multiplied with 2 and the number will become 16, right? So if 2 is written, what you should multiply in order to get 8? So of course it is 4, right? So keep on practicing the balancing of the equation, because in chemistry, if wherever you're writing the equation, it has to be balanced. If you write an unbalanced equation, you won't be given marks, even though your reactant and products formula is absolutely correct, but no marks would be awarded. So make sure that you do the balancing of each and every chemical equation that you write in your pre-board, board, any exam very carefully. That's very important, right? So we'll continue in the next video with the next topic. Till then, keep on practicing the balancing and the previous topics. See you in the next video.